We are continuing with Lab 3, our Hello World exercise about estimating proportions using stochastic gradient descent. We had set up a problem where we have two different boxes of different numbers of red, orange, and yellow beads. And then we defined a way that we were going to pick a box and then draw some beads from that box. Um, Now we figured out the true proportions of the different beads between each different box by using a keep dim um, parameter to the sum method of boxes. So we divided by the total number of beads in that box. Now we're going to define how to make a guess. So we are going to keep a parameters, which is what our current guesses are. We're going to initialize this arbitrarily right now, and then we'll see how we can learn these numbers shortly. But what we're going to do is for each box, we're just going to, at first, think about use the parameters itself as our guesses for that box. We'll determine this is a poor choice pretty soon, but we'll see for right now it works. For box 0, we get 0.25, 0.4, 0.35, and indeed this does sum to 1. So it's a valid probability distribution over these three potential beads. Now we're going to figure out how we can score that set of guesses. So what makes a good guess or a bad guess? There's a little indexing trick that we can use. We've had this example beads, which is uh, the particular beads that we got out that time. And so intuitively, it seems like we did pretty well here. We said 0.4 as a likelihood of drawing one of a bead that would be labeled 1. So we got 3 of those and one of the last ones. So this seems like it should get a pretty good score. So what we're going to do is we're going to look at what score did we get for each one of these example beads. So that first bead was an orange, and we said that our orange probability was 0.4. So this little index trick is going to look up in the example guesses, these probabilities. It's going to look up which one corresponded to number 1, and it's going to pull it from here. So it pulled 0, 1, pulled this value. So it pulls that 1, the value corresponding to 1, 1, 1, 1, and then this is the one that corresponded to 2. So there's the 2 right there. It grabbed this one and pulled it there. Okay, so this is for each bead that we actually saw in this batch. How much probability did we give to it? So that, in a sense, is the probability that we gave to the beads that we actually observed. So here is just the way of doing that again for the guesses and the beads that are actually passed to our score guesses function. So what we're just going to do as a first guess, a first pass at this, is we're going to take the mean of this. We're going to say, well, on average, what probability did we give to these numbers on average? So we'll try that, and it gives a score. We might want to try making better or worse guesses and see what happens. So, like, let's see what if we said that it was pretty unlikely that they gave the first one, and we move some more probability mass to the middle one. So redraw our guesses, and now we have 0.5 here. And we should get a higher score. It went from 0.39 to 0.47. Okay, so we can play with these numbers and see how changing them makes our score better or worse. So this is a good intuition to do. Take a moment and try to play with these and see if you can match up that a better guess gets you a better score.